Yeah, I'm going to do a quick walk around here on this Victor Vapor engine that we've just finished mechanical restoration on. This engine was likely built in Racine, Wisconsin, probably around 1897 or thereabouts. The company Thomas Kane was out of Chicago, but it's kind of they were a furniture manufacturer. It was kind of their big deal down there in Chicago, but they were into a lot of different things. They were building engines for Reagan company out of California real early on in the early 1890s, and built at least some or a bunch of those for Reagan. When Reagan either quit or went out of business or whatever became of them, we believe that Thomas Kane branched out into the engine business briefly, probably only lasted a year or two, and they built their own engine there in the Racine, Wisconsin plant. Probably some later connections to Pierce or other engines too, but that's briefly what we know about the history of the Victor. And this engine, when it came in the shop, it was missing some pieces, and the pieces that were there, a lot of them were in state of disrepair. The cylinder was badly broken. We fixed that, board and sleeved it. Just a lot of extensive mechanical repairs. The vapor system, a lot of that was missing, so we used original drawings, made patterns, got castings made, machined them, but just an extensive mechanical work. Tightened everything up, fixed anything that was broke or damaged. We now have a functional vapor system which works from starting down here at the fuel tank. Obviously pumps up with this pump here, picks liquid gasoline up, brings it up here to the overflow bowl. I'll take the lid off on that. The bottom line is the in, and then the top line is the return. Down there in the bottom is the feed to the metering valve, which drips liquid fuel into the tube, which that tube has a brass screen inside of it, which gives the gasoline surface area to vaporize in. Any fuel that is not vaporized will go all the way down to the bottom here to the return line, which tees in with the return line from the overflow right here, goes down, tees in there, and returns back to the tank. So no waste, no drippage, but this casting here is the preheater. Air is drawn in through these holes in the top, comes down here, through the vaporizer. Supposed to warm the air up a little bit. This is the exhaust pipe inside, which goes through the preheater, provides the heat, and out that way to the muffler. Rotary wipe spark ignition, similar to what's found on some of the early engines like the Foose and others. It's got a side shaft which run off of spur and bevel gears. The side shaft operates the fuel pump off of this eccentric here. You can see the fuel pump back in there. It also operates the igniter, that little dripper that sits over the top of the packing nut, drips oil into the packing, lubricates the igniter. There's a wiper inside, right behind this plate here, which wipes onto a spring wire, which is attached to the insulated electrode right here. That provides ignition. Only sparks when needed, as we have a spark saver. You can see it back in there on the back side of the rocker arm. That is the only makes contact when it's ready to fire. That is the ignition system. The engine has a side shaft for those two functions, and then it is also a push rod on the end of the, see it here, on the end of the exhaust valve. The exhaust valve stem itself is the push rod, which is attached to the rocker arm. Runs on the cam on the side of the spur gear. The rocker arm mounts down there at the lower portion of the base. The hit and miss governing is accomplished by that lever, or that spool in the lever there that latches out the exhaust valve. Let's see if I have it in area here where I can demonstrate that. So this spool is kind of odd because it stays stationary on the crankshaft. It's held in place by that pin that extends out from the base, so it slides back and forth on that. Just a very slight action here by the governor, weights in the flywheel. So when it gets up to speed, it'll lock out there, hold the exhaust valve open, and coast. Some other unique features on this is a very long stroke engine for the size of the bore. I believe the stroke is 9 inches and the bore is only 5. It's got a light crankshaft. Was one of the first things that caught my eye was that machine crank, that very thin webs. Other features, I'll go back to the fuel system for a second. So you have vaporized gasoline in this tube here that is metered by this valve here. On the other side of the intake, which this is the intake valve here, on the other side of the intake chamber you have fresh air coming in. So you got vaporized fuel coming in this side, fresh air coming in from this side through the base. So that is metered by this valve, so you can adjust the mixture of air and saturated vapor air on that side. And this is all kind of an experiment. I've never played with an engine with this type of fuel setup before, so we'll see what happens here in a minute. Victor was big on plenty of fasteners. We have lots of bolts everywhere, studs everywhere. 3 on that side of the valve cage, 1 underneath, and 2 more back in there. They didn't want the engine going anywhere either. It's got 6 tie-down bolts on on the base. Originally, the engine could have been equipped with hot tube, which would have been right there. Someday maybe we'll add a chimney to it or come up with something for that, but for right now we just have it plugged. The patent dates on the tag are go back to some kind of generic patents by a guy named Pennington that was somehow involved with early engine design up in Wisconsin. I think he even had some associations with Henry Ford when Ford built his first engine. But he was kind of a infamous character. He was a bit of a shyster by most accounts. You see his name come up in some of that early engine development history, not always in a good way, but somehow he was involved with Thomas Kane and the Racine work somehow. But big flywheels for the size of the rest of the engine. On the back end we have build a battery box, walnut battery box, coil battery ready to go. Here's some of the pictures we went off of from when we had to make parts for this engine. This engine's just slightly different design, but still pretty close. It's another one out of the early gas engine book. That cover in there is supposed to mount over the top of the spur and bevel gears, and I probably should put it on, but I kind of like watching the gears go around, so it would mount right there. May put it back someday, but it's for now it's going to sit in the toolbox so we can keep an eye on things. And so to start the engine, I'm going to take the cover off of that. I do have a quick release pin down there I could pull out and pump it up with the fuel pump, but it's easier just to pour gasoline in. So we'll grab a gas can. And get a better angle on this. Fill the reservoir up. Once the reservoir is full, we can get the gas dripping, or actually flowing. You can have a pretty steady stream running down there. Back up just a little bit. Have a steady stream running down there. Completely covers that screen inside. And we really can't flood it from that meter because you can control the gas vapors down there with that valve, hopefully. So we just let that run down before we try starting. You should be able to see down here. Yeah, we've got flow coming back, so that means that the screen is completely covered and that gas is returning back to the tank. Yeah, it's about run out now, but we can put a little more in. It should pump it up pretty quickly. There we go. And we've got fuel to it. We can flip the switch on over here. Double throw switch, and I think we are ready for a startup attempt. Okay, I'm going to try to do a quick startup video here for you. Didn't work very well filming with one hand and trying to start with the other, so. Okay. Reservoir's full of fuel. Oilers are on. Got the fuel feed going. Valves adjusted. Ignition is on. We'll see what happens. Fuel pump hasn't quite caught up yet, but it should run for a little while that way. Fuel level's starting to come up now, so we're good there.